How was the battery made? Imagine a world where electricity couldn't be stored for later. Flashlights, remote controls, clocks, watches, cars, and even the smartphone or laptop you're watching this on wouldn't exist, things that are essential to our technology and everyday lives. Luckily, we don't live in that world. We live in one where the mighty battery exists, an amazing creation that empowers all the portable technology we use today, without which we'd be confined to the wall sockets forever. Today, we'll take a deep dive into the shocking history behind batteries and figure out exactly how they were made. Early concepts of energy storage. The start of our deep dive into the realm of energy storage predates the formal understanding of electricity, with ancient civilizations exhibiting early inklings of harnessing power. One notable artifact that hints at an early attempt of storing energy is the Baghdad battery, said to be an ancient battery-like device from Parthian Mesopotamia. Comprising a clay jar, an iron rod, and a copper cylinder, this contraption suggests an awareness of the potential for generating electrical power, although its exact function remains debated among historians. Other than the Baghdad battery, several ancient cultures displayed an interest in the use of static electricity for energy storage, with experiments involving rubbing materials to generate static charges. However, it wasn't until the 18th century that the systematic study of electricity began, laying the groundwork for more deliberate explorations into creating batteries. Regardless, it is clear that even ancient civilizations weren't mere observers, and instead, they actually engaged with and made efforts to understand the world around them, setting a precedent for scientific inquiry in the coming centuries, and also for the eventual rise of the battery. Volta and the voltaic pile. In the 19th century, a significant step in the right direction was made by Alessandro Volta, who you may remember from our video on how electricity was made. Born in 1745 in Como, Italy, Volta was a physicist with a keen interest in electricity. His major breakthrough came in 1800 with the invention of the voltaic pile, a device that could generate a continuous electric current. The voltaic pile consisted of a stack of alternating zinc and copper discs, separated by cardboard soaked in brine, serving as an electrolyte. Volta's innovation marked a major departure from previous experiments, as he was the first to conceptualize the idea of generating electrical energy using chemical reactions. The zinc and copper electrodes immersed in the electrolyte underwent oxidation and reduction reactions, producing a flow of electrons. This groundbreaking invention not only demonstrated the feasibility of continuous electrical current, but also provided a practical source of power. The voltaic pile became a crucial component in early experiments with electricity, opening new avenues for research and inspiring further developments in battery technology. Volta's work laid the foundations for electrochemistry, and the unit of electromotive force, the volt, was named in his honor. If you feel yourself energized by this video so far, by the way, please feel free to drop a subscribe to the channel so you don't miss out on more content just like this one. Thanks. Development of electrochemical cells. The mid-19th century witnessed the continuation of advancements in battery technology, with Michael Faraday playing a central role in elucidating the principles of electrochemistry. Born in 1791 in London, Faraday conducted extensive experiments that led to the formulation of Faraday's laws of electrolysis. His work laid the groundwork for understanding the relationship between electricity and chemical reactions. Faraday's contribution came from his exploration of electrochemical cells, devices that convert chemical energy into electrical energy, similar to the voltaic pile. The principles he discovered became fundamental to the design and optimization of electrochemical cells, further shaping the trajectory of battery technology. The mid-19th century thus marked a pivotal period where theoretical insights into electrochemistry began to align with practical applications. The foundation laid down by Faraday not only enhanced the scientific understanding of electricity, but also propelled the development of electrochemical cells, setting the stage for diverse battery types that would emerge in the ensuing years. Lead-acid and alkaline batteries. In the late 19th century, another transformative development was made in the world of batteries, with the introduction of rechargeable batteries, offering a sustainable solution for energy storage. Gaston Planté, a French physicist, ushered in this era in 1859 with the invention of the lead-acid battery, a milestone that paved the way for portable power sources that could be reused. Planté's lead-acid battery utilized a combination of lead dioxide and sponge lead immersed in a sulfuric acid solution as electrodes. The key innovation lay in the battery's reversibility. It could be recharged by reversing the chemical reactions that occurred during discharge. This breakthrough marked the birth of the first practical rechargeable battery, finding early applications in the emerging field of electric vehicles and later becoming a staple in the backup power industry. The lead-acid battery's ability to store and release electrical energy repeatedly was revolutionary, offering an alternative to disposable batteries that were prevalent at the time. This development addressed the need for reliable and rechargeable energy sources, laying the groundwork for the evolution of battery technology to meet the growing demands of an industrializing society. Later, in the mid-20th century, came the next big leap forward, with the development of alkaline batteries, offering greatly enhanced efficiency and reliability. Louis Urey, a Canadian inventor, played a crucial role in this advancement, creating a battery that would become synonymous with portable power. Alkaline batteries, introduced in the 1950s, departed from the traditional zinc-carbon chemistry. Urey's innovation involved using manganese dioxide as the positive electrode, zinc as the negative electrode, and an alkaline electrolyte. This composition significantly improved the efficiency and energy density of the battery, leading to longer-lasting and more stable power. This greatly increased efficiency created a paradigm shift for portable power, quickly making batteries the preferred choice for a range of electronic devices, including flashlights, cameras, and portable radios. The Lithium Ion Revolution. The late 20th century saw a revolutionary breakthrough in battery technology with the advent of lithium-ion batteries. Developed by a trio of scientists, John B. Goodenough, Stanley Whittingham, and Akira Yoshino. In the 1970s, lithium-ion batteries marked a groundbreaking advancement in portable power solutions. Lithium-ion batteries are characterized by their use of lithium ions as charge carriers, moving between the positive and negative electrodes during discharge and recharge cycles. This design offers a high energy density, lightweight construction, and a longer lifespan compared to previous battery technologies. The impact of lithium-ion batteries on consumer electronics has been profound. These batteries became the powerhouse behind the rise of laptops, smartphones, and other portable devices, offering a reliable and high-performance energy source. Moreover, lithium-ion batteries played a crucial role in the development of electric vehicles, providing the necessary energy density for practical and efficient electric transportation. It was truly a whole new era in battery technology, and the number of electronic devices that are powered by this technology to date is massive. Battery technology today. Stepping into the 21st century, battery technology continues to evolve ever more, driven by the quest for even higher efficiency, safety, and sustainability. A very notable and promising research area is solid-state batteries, which, unlike traditional batteries that use liquid electrolytes, which can pose safety concerns and limit energy density, makes use of solid materials that can offer potential advantages in terms of safety, energy density, and longevity. Researchers aim to overcome technical challenges and bring solid-state batteries into mainstream use, revolutionizing the landscape of energy storage. Another avenue of exploration involves graphene batteries. Graphene, a single layer of carbon atoms arranged in a hexagonal structure, possesses remarkable electrical conductivity and mechanical strength. Incorporating graphene into batteries can enhance conductivity, improve charge-discharge rates, and potentially lead to longer-lasting and more efficient energy storage solutions. It is common belief among researchers that the next big battery revolution is coming, and the research into these contemporary technologies may very well be what brings it about. Concerns and conclusion. Despite the remarkable strides being made, the industry does face some challenges that require solutions. Producing advanced batteries is a very costly process, and making these technologies more affordable remains a hurdle for widespread adoption. Environmental impact is also a concern, as the extraction and processing of materials used in batteries, as well as the disposal of used batteries, raise concerns about sustainability and potential ecological harm. Addressing these issues involves not only improving recycling methods, but also developing batteries with eco-friendly materials and manufacturing processes. Then there's the issue of resource availability. Battery demand shows no signs of decreasing, and ensuring a stable supply of raw materials is crucial. We don't exactly have unlimited amounts of these things, and research is being made towards alternative materials and improved extraction processes to help mitigate some of the scarcity. All challenges aside, however, the future prospects for batteries are still very exciting and diverse. Emerging technologies like quantum batteries and bio-inspired batteries are under exploration, presenting unconventional approaches to energy storage. This intersection of diverse scientific disciplines, coupled with technological innovation, puts the battery industry in a great position, and I, for one, can't wait to see the amazing technology they end up powering. Hope you learned something. Thanks for watching.